Now, last but not least, let's talk about fixing a weird bug you might run into on iOS. On iOS, when we use observable collection for our collection view, sometimes you'll see a weird bug where the app crashes like this. There we go. So it immediately crashes with this weird error about a system argument out of range exception, must be a non-negative number and less than the size of collection. And there's not a lot of useful information in this error. Errors like these are not uncommon in .NET MAUI because we have the .NET runtime, we have the Objective-C runtime, we have all sorts of different layers going on in our applications. So what's happening here is that the collection view is being told to update. So to be very specific, exactly what's happening is this behavior is triggering. And this behavior is getting down to this line of code where we're adding libraries to the observable collection. So this is our MAUI libraries observable collection. And every time we add a new library to it, then the observable collection triggers iNotify changed. iNotify changed tells the view to update the collection view so that the user can see it. But in this case, our code here in the view model is literally moving too fast because for the iOS collection view to update itself, it takes some time. But the way iNotify change works is it's kind of fire and forget. So what's happening here is we're calling MAUI libraries.add really, really fast. We're here in this for each loop. And iOS is getting that notification from iNotify change, telling it to update. And it's doing its best. But the problem is, as it's trying to update one row in the collection, another notification comes in telling it to update and it goes, okay, I'll do that right away. And then all of a sudden, it's got conflicting notifications. It doesn't know which row to put in where, and our app just ends up crashing. So there's a really easy solution to this. And the solution is to marshal everything to the UI thread. So the UI thread, if you've never heard of it, this is the main thread of our app. This is thread 1. This is the thread that runs when we launch the application. And it's also known as the UI thread because only thread 1, only the main thread, only the UI thread is able to draw UI onto the screen. So what's happening is we're telling the UI thread to update. The UI thread is quickly trying to update the UI collection view on iOS. But then as it's trying to do that, we're telling it to update it itself again, and it's going to try and do that really quickly. And again, everything's getting out of whack. But since we know that iOS only updates the UI using the main thread, if we marshal this line, MAUI libraries.add, this line too, MAUI libraries.add, if we marshal these lines to the UI thread, then we know that our work will be done only on one thread. And because the UI thread is the same thread that's going to be redrawing the UI for us, what we end up doing is adding these notifications, these commands to a queue. So we don't invoke iNotify change back to back, telling our UI collection view to update itself and then confusing it. Instead, we essentially queue things up on the UI thread. Now let's jump back into the code to see how we do this. So the first thing we're going to do is we need to access what's called the dispatcher. So in our constructor for list view model, I'm going to pass in iDispatcher, and then I'm going to save the value of iDispatcher into a read-only field here so that we can access the dispatcher anywhere in our list view class. So the dispatcher, if you've ever done any other .NET development before, it might sound familiar, especially if you've done anything with UI like WPF, WinForms, even ASP.NET Core have the concept of a dispatcher. But we can think of the dispatcher as a way to marshal our code from whatever thread it happens to be on to the UI thread. So we can essentially dispatch code onto the UI thread. Now, all I have to do here, since we're using shell, is to tell shell to give me the dispatcher. So there's actually nothing more we have to do You might think we have to come into here and say builder.services.add and pass in a implementation of iDispatcher, but we don't, because .NET MAUI actually does that for us under the hood. So iDispatcher is already available in our service collection, which means we can just easily add it as a constructor or into the constructor via dependency injection. Shell will give us this variable, and then we'll save it here as a read-only field. Okay, so now that we've done that, we want to do a couple things. We want to come down to our, there it is, user stop typing behavior command. And the first thing we need to do is we're going to start using async await. So let's change this to async task. And the good news is relay command can totally handle async tasks. It'll take care of this all for us underneath the hood. It's basically regenerating this command as an async relay command instead of what it used to be, an relay command. And now that we have access to async await and the dispatcher, what we want to do is say dispatcher, dispatch async, and anytime we modify our MAUI libraries observable collection, we're going to tell it to, instead of dispatching it right away, first marshal that to the UI thread, then dispatch that command. And then once that's done, by using async await, then this next line of code will run after this code has been dispatched to the UI thread. Let's go ahead and add that in here as well. And let's add that in here as well. And now let's run the app and see what happens. And look at that. Our collection view refreshed without crashing. We can tap on anything in our app and everything works just like we expect it to. Except I will say the app does look a little ugly on iOS because we were mostly focusing on implementing these features in Android. But this is also very common and something you should be aware of as you make your .NET MAUI apps is make sure to check it on both platforms. Now, usually I'll focus on one platform. And then when I'm done implementing all these features like the search bar and the user stop typing behavior, then I'll come back and edit things like you can see the text here doesn't really show up black on black. So we need to edit this background color for the iOS search bar specifically. Always make sure to do this, especially before you release it to any users, because again, .NET MAUI uses the native UI controls under the hood, and it uses their corresponding default values. So if the default value for, say, the search bar on iOS is this color, I'm actually not sure if it is off the top of my head, but let's assume it is, then this is how it's going to look on iOS if we never define a color. Whereas if in our code we define the color as white or blue or transparent, then .NET MAUI will assign that color on both platforms. So sometimes the defaults look great on Android, but look bad on iOS. And sometimes the defaults look great on iOS, but look bad on Android. And that's on us as cross-platform mobile app developers to make sure to go and fix. So we won't get into that now. You can take a look at the finished code that looks great on both iOS and Android. Let's run this app. Let's make sure everything still works just like we expect it to. And then we'll move on to our next section.